Okay, so let's get started. Again, we've got most people back, just a few people missing, so we'll get started where we are. So, so this morning we mostly looked at basically introducing containers and what they are, and then also a bit about how to run containers and also managing both images and containers as part of Docker. We also had a brief look at Docker Hub and had a bit of a chat about how you decide whether the image you're choosing is potentially trustworthy or not. Now, of course, it's great being able to use images that are already out there that other people use, and there's actually, you know, that covers a large amount of use because there's so much out there. But we're talking about this session is really about people who are working in research most often. So one of the things that's always going to happen is, you know, you're going to be able to want to create your own container images, either for yourself because it's convenient and it's a convenient way of working, also to capture what you did and potentially aid with reproducibility in the future, either for your future self or for other people, or to package up something that you've built, a pipeline, a workflow, some sort of tool, so that other people can use it more easily. You know, for example, we'll talk about Singularity tomorrow, but one of the things we've been doing on ARCHER2 is some things that are quite difficult, that maybe have difficult dependencies to get up and running on a HPC system. Often analysis tools, particularly graphical ones, can be quite challenging to get working on the system. So one way to short circuit that is to create a container with the analysis tool, and even the graphical analysis tool, and that allows us to move forward and get people up and running quickly without having to worry about changing how the login nodes work or how the compute nodes work, you know, because you can just encapsulate all that in a container and just avoid all those problems. And that's creating something for other people, for the rest of the user community on the HPC service to use. So, you know, often the real power, or one of the real powers of containers is when you can create your own container images. And as we'll see, that generally doesn't mean starting from scratch. That almost always means starting from building on top of what somebody has built before. So we'll talk a bit about that this afternoon. Talk a bit more about advanced uses of containers and getting data in them, and then finally we'll finish up with some bits and pieces about reproducibility and what that actually means in terms of containers, and what the sort of things you need to think about are around that. So this first little episode about creating your container images, we're going to look at how we can make your own Docker images and how you document the recipe for creating a Docker image, which is encapsulated in what's called the Dockerfile. And we'll do some demonstrations and hopefully give you a chance to see it happening, and also have a go at it yourself on your own system. And I've already talked about some of the reasons for creating your own Docker image, right? And they're mentioned here too. But before we go on to look at creating your own container image, let's look at, you know, what we can do within a container image to build on it. So let's start run our Alpine. Hopefully you've still got your Alpine image. If not, it will automatically get pulled down again. But if you've still got your image there, it should be very quick. So we're going to Docker run -it Alpine, and if you remember, this gives us an interactive shell within the container, within a container that's running the Alpine Linux distribution. Now, this is a really basic container. It's a vanilla install of the Alpine operating system. So it doesn't come with that much installed. It only has the very basic stuff, and we sort of knew that, right? Because we had to use sh rather than bash as our shell, and bash is a much more normal choice for when you're running on Linux nowadays. So, but one thing that people might often want to use is Python. So let's have or Python 3 in particular, because, well, let's not talk about Python 2 anymore. It's been deprecated, and yeah, nobody mentions it anymore. So if we try to run Python 3, we'll see it's not found, and that's because it's a basic container without Python 3 installed. But we can, of course, install it, because in this container we're super user, we have root, so we have administrative privileges. So we could use the Alpine installation command, which is APK, obviously for different for different flavors of Linux, it's different things. It may be Yum, maybe Zipper, it may be apt-get or something like that. But let's try let's use APK, which is the Alpine package management, and we're going to add Python 3 and pip and the Python headers as well, which are important for compiling other tools and making certain Python packages work. Okay, and you can see this works as expected, right? So what's happened here is it's gone out to the Alpine package manager across the internet. It's found those packages, it's downloaded them into our container and installed them for us. So now, okay, we've installed Python 3 and we have a working Python 3 within our container. Okay, so basically we can actually use Python in the container now. And we can even now use pip, because we install pip, we can install additional Python tools. So let's install Cypher on top of our existing Python 3. And you can see it does the same thing. It's a package manager. It goes to the internet, gets the installation stuff we need, and installs it into our container successfully. Okay, so now we have this container where we've added extra tools that we need. Now, obviously, this is a synthetic example because you've already seen that on Docker Hub there are already Python images available, so you wouldn't need to do this yourself generally. And to add Python to an image, you just start from one of the Python images. But we're illustrating the point here. And it is one of the exercises here is, can you have instructions for installing R on Alpine Linux, and do they work? So we could try searching for such a thing. So let's have a quick look, and blah, blah, blah. I'm trying to do and it just, the first answer on Stack Overflow, which is obviously the most trustworthy website in the whole of the world, but there we go, is APK add R. So let's just try that, see what happens. And off it goes. It's a bit of a bigger install than Python, but it seems to be installed. Okay, so we've now installed R as well, 4.1. Okay, so that's just like working with normal Linux, except we're in the container here, right? APK is not a command that's available on Mac OS, which is my host system. It's only available in the container because it's only available as part of Alpine Linux. Okay, but once we exit this container, okay, if we start an Alpine container again, we're back where we started. All the changes we made have been lost in some sense. They haven't been completely lost because, as we noted before, containers in Docker don't just disappear when you exit. They go into this exited state. So I could potentially get back to the container I had before where Python 3 will be installed because it's still exited. But if I did prune and removed and deleted all the containers, it would be lost. So, for interest, if I show you what the containers, because this is a useful thing to know as well, Docker container, ls, and of course minus all to show the stopped ones. So the one I stopped longer ago was the one I did the installs on. So it's this one from 5 minutes ago. I can restart this container and get back into it with my changes in, as long as it's still in this exited state. It hasn't been deleted or pruned. I can use this by using docker start, the container ID, and then that shows the container started up again. And then there's a docker attach command, which will take me back into the shell. And you should, hopefully, Python 3 should still be there because I've restarted the old container rather than starting a new instance of the Alpine Linux image. So let's go. That was a sort of sidetrack to show that you can get back into the container. Now, there is a way to snapshot what you've done to this container. So take this container as it is with the Python 3 installed, snapshot it and use it to create a new image. But that, which is fine, But that doesn't really help us in terms so much of reproducibility. Okay, we have an image we can use, but it doesn't have a record really of what we did to get to that image. And the way we could do that is instead of going into the container interactively and installing all the extra things we want, we could define what installation commands we want to use in something called the Dockerfile. And then we could use that Dockerfile to build the image instead. So then we have both the image, which is the thing we want to be able to create containers and redo the stuff, but we also have the Dockerfile, which is a record of what we did to get to that image. Okay, so people could build on that and reuse it, understand exactly what versions and what commands we ran to get to that state, which is really, really important in terms of reproducibility and reuse of the container images. So let's show how we can do that in the Dockerfile rather than just interactively in this way. So as part of the setup instructions, you are asked to download and unzip a file. I will go back and do it to show you. So I haven't done it yet, so I can do it right now. So I'm going to go back to the setup page on the course website. And then the second one is the file to download, and it's got this link here to this file. So I'm going to copy that link address, and then I'm going to get it onto my host. Okay, so that's downloaded the docker intro.zip, and I'm going to unzip that file. Okay, and if we look again, that's created the Docker intro folder. So we're going to go into Docker intro, and we're going to go into basic. Okay, and that does contain a basic Docker file. Let me go back to the episode. It does contain a template Docker file, sorry. Where are we up to? So put the installations into Dockerfile. So I've CD'd into Docker intro basic. It could be on the desktop, it could be elsewhere, depending on your local system. Hopefully you've got that file already. But all the Dockerfile contains at the moment, you can edit using whichever editor you want. You could access it through the file browser on your computer and just use TextEdit or whatever tool. I like VI, so I'm going to use VI to edit my file here. You can see this file contains a few sections: from existing image, some install commands, and the command to run by default. So we're going to try and fill this in based on what we did before. The first line, the from, says it says here which container we're starting with. That's wrong actually. Which image we're starting from? Where's the base image we're going to build on top of? You always have to start from somewhere. The next two lines, the run commands, indicate the installation commands we want to run. These are the same commands that we ran interactively. So if you remember, we did two installation commands when we first did our thing. We did the apk add, update Python 3, blah, 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 and we did a pip install Cython as well. Okay, I'm not talking about the R installation as well. And the last line, the command line, indicates what we want the default command to run when somebody types docker run and the name of our image. Excuse me. There are slightly different ways of writing this. The preferred format is this one that looks like a list of commands, so a list of parts of the command. So instead of having just ls minus lf color / etc, the ls is the first entry in the list, minus lf the second entry in the list, color exec, and so on and so forth. That's the recommended form by Docker, and that's the form we're going to use here. There's a call out here. You can use the shell. You can make both forms work, but the second one's is the recommended usage and is more explicit here. So it says, do we have any ideas about what we should use to fill in the sample Docker file to replicate the installation we did above? Well, I've given you a couple of hints. So the run, the first run command, which should be the first installation command we did, which is that one. And the second run command should be the second installation we did, which is this command here. So given that, can you go away and fill in the other two, have a guess at filling in the other two sections, the from and the CMD sections in this Docker file on your local system? I'll give you probably, it's 13:46 now according to my computer clock, so I'll give you maybe for 3 minutes or 2 minutes to have a go at that. So we'll have a look again about 1348 and see and look through the solution to this. But I'll have a go first and see if you can have a guess at what it should look like to replicate what we did above. Okay, hopefully you've had a chance to have a guess at that. Maybe you've looked at the solution, maybe you haven't. But what we want to do here is the first thing that specifies where we're going to start from. Okay, and in our case, that's Alpine. We start from the image that was called Alpine. Okay, and then the command we ran, if you look back, the command we ran was actually just -3 version to check the Python version. So very simply, if we put that into a list, we end up with Python 3 -version, like that. Okay, and hopefully my thing here matches the solution down here. Okay, so what we've done there. It only looks a very simple thing, but we've captured the commands we wrote in a file that is both human readable in some sense. It provides a record that I could look at and see what actually happened in the image to set it up how we wanted. But it's also crucially can be used by Docker itself programmatically to create the image file. So let's actually try and build the container now. To do that, we use the Docker build command, and to that we provide it with a couple of pieces of information. We provide it with the location of the Dockerfile, and that's not actually the path to the whole Dockerfile itself. It's just the directory that the Dockerfile is in, which is a little bit confusing. The Docker already knows that the file should be called Dockerfile, which is what we've called it. So you specify the directory it's in, not the name of the file itself. And then the name for a new image, which is often called the tag, which is why it uses the -t option to specify it. You should generally name your new image with your Docker Hub username and a name for the container with username/container name. The reason for this is it makes it easier to push up to the Docker Hub in the future, and it gives you a unique name as well because you're prepending your username all the time. It provides an easier way to track which images are yours, ones you've created, and which images you've got from somewhere else. Okay. Excuse me. So let's try this with our one. So we're going to call it Docker build. So let's do that. Docker build. I'm going to give it the -t flag to give it to specify the name, the tag for it. I'm going to use that's my Docker Hub username, and then it's going to be called Alpine Python. Okay, so it's Alpine. It's basically the Alpine image. It's got Python in it. And the final thing I need to provide, which I always forget to do when I'm not teaching you, and I haven't got it written here, is provide the directory where the Docker file is. In this case, it's just a dot because we're actually in the directory with the Docker file. And on command line in shell, if you're used to using Linux-like shells, dot always refers to the current directory. Similarly, dot refers to the directory above. Okay, so that says build the Docker container, give it this tag, this name, and use the Docker file in this. Use the file name Dockerfile in this directory. So let's try that and have it see what happens. Okay, so what it did very quickly, because it cached this. In fact, let's try that again. So what I'm going to do is remove the image that I've just created and prune my containers so it doesn't look as quick because I think some of the information was missed there. So let's Docker image rm. I can remove the one I've just created, which is this one here, the APC A10 APCC Alpine Python. Okay, and then I'm going to do Docker container prune. Just get rid of everything. Okay, so let me try building again. This time, maybe it'll take longer this time. Oh no, the cache is too clever for me. it still sits somewhere where I don't know about it. So one of the things it's doing here is because it knows, and it's already done these commands once already interactively, it's just cached how to do them. So it doesn't take very long at all. If I'd done this before I'd actually done the interactive installation, you would have seen the output from these installation commands here as they ran in the container. Okay, and what that should have given, right, is so we did specify a tag for our image name, and what command runs the. So we've already seen how to list it. And that's the answer to question 1 here, which is Docker image ls, right? Because that shows us all the images we have, and this is the one we've just created here. Okay, so it's there. And what command do you think the run that container you created? Well, we saw in the Dockerfile, we'd set it up to run Python 3 version. So hopefully, if we do Docker run, the name of our new container image, we get the output of Docker of Python 3 -- version out on the command line. Okay, so quite quickly we've gone from what was in the Docker file to a working container image that we can then use to run containers and do the thing we wanted to do. In this case, not a very complicated thing at all. Okay, and these keywords that are in the Docker file are all well documented on the Docker website. Okay, and we'll see some more of them later, but there's a wide range of them for doing different tasks when you build container images. And it doesn't feel like we've done very much there, right? It was a very simple file. It was very simple commands. They ran very quickly. But what you've actually done at this point is create a container image that contains a lightweight Linux operating system with installed with the tools that you're interested in and you want. It's been documented, and you've ended up with a container that will run this command in some sense, no matter where you ship it. So, I could take this container now, this container image, and run it anywhere else that Docker runs, and potentially other tools. I just see tomorrow, Singularity can also take Docker images and work with them. So I could now log on to, say, any system that had Singularity and use this Docker image as I wanted. Okay, but there are some things to consider when you're creating your own Docker images. It says here they're boring but important notes. I'm not sure they are boring. It depends. I guess it depends on your outlook on life. Maybe I'm just a boring person because I don't think they're boring. But anyway, things like some things to consider. As I mentioned before, start from the right place. In this case, we've illustrated it by installing Python 3 in Alpine, but of course you would never start that if you if your main tool was based around Python or Python 3, then you would start with one of the official Python containers. Same with something like you'd start with one of the Rocker images, likely. If you're doing something more generally around Linux, then Alpine's probably not the right place to start for testing. It might be the right place you end up after a bit of testing, because you want that lightweightness, you want to be efficient in terms of memory use and size of downloads and things like that. But I would not, because I probably wouldn't, if I was doing something for the first time and trying to build a tool that worked, I'd probably start from something like Ubuntu or CentOS first to try and get started, because they're more fully featured normal versions, common versions of Linux, and will be easier to get something up and running with. There's potential for optimization by using lighter weight images later down the line. But in the first step, I would certainly go for something more mainstream to start from, I think. How big? What do we need to install? Okay, so, should you add everything? Because typically what you do with your own host system is you have a lot of software and a lot of tools installed. So actually you install a lot of things on your host system. But the opposite's probably true in a container image is you want to minimize the things you install. So don't add things that aren't needed to run the software and the tools you're interested in. It's almost some, and we'll talk a bit about granularity later when we talk about reproducibility, but there are some choices to be made initially about whether you put everything into one image for your workflow, or whether you produce lots of smaller containers and then build up a workflow from using all those smaller containers. I'll talk a bit more about that later, but there's definitely a choice to be had there. No, or the equivalent of no these days, because I don't know anything, because I'm like everybody else, I'm a cyborg. Most of my knowledge actually resides in the computer or in a digital device somewhere, because I just remember how to use Google and how to use Stack Overflow. No, or Google your Linux. You know, how would you install different things on different Linux things? So, you know, you'll find when you're building container images, often one of the first steps you'll be doing is apt, is the things like we used APK for Alpine, but things like apt or apt-get in Ubuntu. Debian uses Deb, CentOS uses Yum. If you end up with SUSE, you'll have something like Zipper. You know, understanding how to use those tools and what's available in those Linux distributions, or being able to Google it effectively, is certainly a useful skill when you're building images. So, you know, and finally, use what you know, right? For example, if you already know how things work through using pip or using R with install packages, then you can reuse that information when you're building your images. Essentially, as you've seen here, these run things are just commands, just Linux. They're equivalent of typing that on the command line, but doing it also, it does it automatically for you when you build the image. So, you know, if you know how to do that already on the command line, reuse that knowledge when you're building your images and building your Docker files. And the other thing I'd say, you know, is think ahead a bit and try and plan your strategy. A list of what you want to install, look for pre-existing containers, the best starting point. Read through the instructions. You could try installing everything interactive in your base container and take notes on what works and what doesn't. And then finally, using those notes, create the Dockerfile and then run the tests. And then once you've got to that stage and you've built your image, the next step is how do you get it out there to the world? Now, I'm not talking here about the reproducibility and the archiving aspects. We'll talk about that in more detail towards right at the end of the session. But the first place you could put something where somebody could easily get it with Docker, because we've seen how easy it is to interact with Docker Hub via the Docker command line, is just to push it up to Docker Hub. Because when we created our image, we gave it a name that included our Docker Hub username, and that makes it very easy to push straight up to Docker Hub. So there's a Docker push command. So let's just try that with my newly created Docker image. Docker push. I should have just pulled and copied and pasted this. That would have been the easier way to do it. So you should be able to do this with your one. Hopefully your ones that you created, as we're going along here, have your Docker username in. So it adds a default tag latest to it. So that's the bit that goes past beyond the colon in the Alpine Python. Here, if you remember the tagging when we were talking about Docker Hub usernames, it was user repository tag after the colon, essentially. That uniquely identified an image. It's working. Then to push stuff up. Of course, it's a bit slow because I'm also sharing my video with you, my sound with you at the same time. So I'm sort of saturating my bandwidth from my Wi-Fi. If I'd been connected in at the office using my wired connection, I think it would have been much quicker. But we're almost there, hopefully. Okay, so fine. So you can see it's actually done two things. I mean, I want to say a bit more about what it's done here. Right back at the start, and when we were talking about Docker containers, we talked about file systems. And I think I briefly mentioned the word layers. And each Docker image is made up of layers. And each of these layers is essentially a file system overlaid on top of the one below. And the reason Docker has made that choice of how to do things is to try and save space. And you can sort of see it. Jacob says he gets denied, request access to resource denied. So you need to make sure you're logged in to Docker Hub. You can do, I think there's a Docker login command, which tells me I've logged in and succeeded. So you can try that. Also in your sys-tray or wherever the Docker desktop icon is here, if it's not showing your username, in the list, there should be a login option up there where you can log into Docker Hub up there. And IOS says, it is given the tag as latest. What if we run this command over a single image multiple times? So we'll talk about this. This is why the Docker Hub isn't, or these sorts of things aren't very good for archiving, is it'll just keep overwriting it if you don't say latest. It'll just keep overwriting the latest one. But you can, you'll see in a minute, we'll give some of our more advanced images different tags, and so you can have multiple versions. You'll see how to do that in a minute. Okay. So I was talking about layers, and so one of the reasons Docker uses layers is so it can save space and save on upload and download amounts. So my image I've created consisted of 3 layers. That's why there's these 3 things here with the different hashes, and 2 of them were pushed and one of them was mounted. The 2 that were pushed were my pip install Cython layer and my APK install Python 3 layer, okay? Because they were things that I'd done uniquely within my Dockerfile to create my Docker image. The final layer is the base layer. So it said it was from Alpine, okay, which is something that Docker already knows exists on Docker because that's where it came from. So rather than upload it again from my image, it said, that's something that already exists. That's a standard one from Docker Hub. So actually all I need to do is say that it's that one there and point at the right one in the Docker Hub. And then my image that I've uploaded is constructed of these 3 layers. One which is taken from the library, which is the base Alpine stuff. An extra layer which I've uploaded, which was the Python install. And then another extra layer I've uploaded, which was the pip install Cython. Okay, so all Docker images are like this and consist of layers. And that's for efficiency reasons, both in your local storage and in terms of moving images around via Docker Hub. Okay, Evan, then maybe one of the helpers can come and help you out if you're still getting access denied despite the login succeeding. That seems strange. And if you're logged in, it should work. I've not seen that particular problem before. Well, assuming at some point you successfully managed to upload your image or push your image to Docker Hub, then when you go to Docker Hub itself, let's go here. Okay, so here I am. And when I log in, actually, it's taken me to my own space. And if we look here in where my space is, my repository, it's not very good. It's not formatting very well because it's a bit wide. It's not wide enough. You can see that it's created Alpine Python. The last push was 4 minutes ago, and the only tag available is latest. Yeah, which is the one that I got pushed up. So there's me, and this is the image that I pushed up a minute ago, and you can see it has the various different layers, and what was the Docker file that we used to construct this image automatically pushed in there. Okay, it has no documentation because I haven't added that sort of stuff yet. And if I really wanted people to use this image, I would be I would be adding documentation and usage instructions and things like that around the image here, around the image details onto Docker Hub. Okay, so somebody asked about the tags and the names and how the tagging is working. Excuse me. On your own computer, you can call them what you want. It's only when you push up to somewhere like Docker Hub that you have to have things like the username in it. So you can't rename. Say by mistake you're working with tin, if you get to give it the proper name or the proper tag, you can change the name with the Docker tag command. So say I've called something locally workflow test, but then I want to move it up to Docker Hub. I can rename that image using the Docker tag command, and then you can push up to Docker Hub in that way. Okay, so hopefully I know some people seem to have problems with the push, but we'll hopefully get them sorted out. But you should have seen from this little episode that the Dockerfile is the key thing. That specifies what's within the Docker image, and then the combination of the Docker build command with the Dockerfile allows you to create your own images. And then once you get your upload sorted out and the way that works, you can share your images through the Docker Hub so that others can create Docker containers from your images. Because either can use them as the base for creation or could use them directly as they are as well. Okay. Happy to take any more questions on Docker files before we go on to the next section, which is about more complex stuff.
Hey, Andrew, I have a question. How common is it to use the command on the Docker file? So, I mean, I expect we will build container, and then with the software required, then people use it as they want. Yeah, we have many examples where there is a command that is the default. What's your what's the general approach?
Okay. No, I understand the question. So it depends how the image is going to be used or how the container is going to be used, right? So if you were building, say, part of a genomics workflow, I'm not a genomics researcher, so I may say things completely wrong here, but if that's going to run a particular tool, you know, and its job is to run this tool with a specific set of options on a data set, okay? And then you might want the command to just work to say, you know, actually, what I'm doing here is not using this tool in the general sense. I'm using for this specific purpose. So you're creating your Docker, your container then becomes like an alias to running the command, but with all the tooling installed within the container. So it has that use case very often. So you often see people use commands, or as we'll see a little bit later, entry points when you want to use the specific tool specifically. So to say you built up the Python containers, you've seen the official Python containers on Docker Hub.
Yeah.
They do have a command built in. The command they run is generally Python. Okay, so you can give it, you can type Docker run and the name of that container, and then just give it a Python script at the end, and it'll just run it. So that makes it super easy to use, right?
Yeah.
Because it behaves just like Python. So it does, but some containers may be designed to be used to actually have an interactive shell and then use the tools that are inside the container to do what you want to do. This feeds in a bit to that thing I briefly mentioned a moment ago about what the granularity of container is. Are you creating one big monolithic thing that people might then access interactively, has all the software to do all their workflow, or do you create lots of little containers that each run a specific command that you can then clip together to do the workflow? You know,
yeah, I'm very interested in this. Yeah, okay. I'm looking forward to discuss this later then. Yeah. I think we're covering it later, no? That's what you said?
Yeah, yes, yeah.
Okay,
we'll have a look a bit more about that later. But it's an open-ended discussion, right? I mean, there's no right way to do things. I would point that out. It really depends on what your use case is.
Okay, thank you.
So anybody else, any other questions before we move on to the next section? So Mark says, can multiple users log into a container, or is it per user that started it? So generally, so I'm not, this isn't something I've tried. Almost all the uses of containers I've seen is a single user using it, but that's not strictly true, because one of the common uses for containers, certainly in the cloud, it would be to run a web service, right? And so if you had a persistently running container that was running sort of web service, either a database connection or something like that, then you would have multiple people accessing it, accessing the container via, say, a web address or something like that. Okay, so it depends on your use case. I mean, in the ones we talk about here, most of these are single user ones, but you can use containers to run other things that expose services to people, and then multiple people can access it, and then multiple people can access it. Now, whether they log into the container as separate users, or whether, you know, it's not quite logging in because it's like a web service, so it's handled in a different way. It depends what you mean by login in that case. It gets more complicated, but certainly multiple people could use a container at the same time. And Matteo says, can we add local files to a container? Or an image. That's what we're just going to talk about. Okay. For a particular OS, e.g. Ubuntu, or the RC local services initiated, depends on the image you're starting from, I think, and how it starts up exactly. You need to look at the individual containers, the individual images, and try them out to know what's going on. Oh, there you go. Jeremy's got a better answer than mine.
So just to answer Mark's question, normally if you're wanting to run a number of things at startup, then you would use something like supervisor. So I believe if you don't, I think whatever you start when you run the container basically starts as kind of process number one. It's like the master process. So that's why you'd normally use something like supervisor to start as kind of the main process, and then you'd use that to start any other services that you want to start. So it doesn't boot up like a regular operating system effectively. I hope that answers your question.
No, that's a much better answer than mine. Thank you, Jeremy, for explaining it more better. So Mark, I'm not sure what supervisor is. Maybe Jeremy can provide some links in there. I think it's slightly out with for this course, so I'd like to move on to the next bit if that's possible. So we've done something very simple, but generally most container images are a bit more complex, particularly around data. Okay, so things like accessing data from the host system within the containers, right? Because obviously you usually want the container to do something to some data, and usually that data won't be in the container. It won't be in the container itself. It will be on the host system somewhere, or externally on the web or something like that. And you may also want to include data in the image from your host system, but is encoded in the image so that when it's distributed, people have access to that data as well. So this is mostly about using files and scripts right outside the container within the container, either on the host system or elsewhere. And so we're going to talk a bit more about that as we go through this little episode. The examples sort of build up and get more and more complicated. There's a few extra bits at the end. I probably won't cover them, but just to be aware, if you're interested in looking at them, they're at the end, and I'm happy to take questions on them if you look at them and have more questions. Okay, so let's change to instead of looking at the basic one, which was where we were here, we're going to go into the sum subdirectory of the thing we expanded, the Docker intro zip file, and in there's a small Python script that adds up all the values that's given on the command line. I've got Python on my local system here, so I should be able to do something like python sum.py 1, 2, and it'll tell me that the sum is 3. Okay, so that's what that Python script does. Okay, but so first thing we want to do, we built our Alpine Python image with Python 3 in it. So you'd think, let's try and use that to run this thing. Now, the command we gave it originally, the default command is Python -" version, which isn't very useful to us. So we're going to have to overwrite the command. So let's try. Sorry, I'm starting the wrong place. Docker run, and it's going to be the. I'm going to scroll back up here just because I'm the laziest person in terms of typing the world has ever seen, and get that from there. And I don't want to run the default command. I want to run the Python 3 command, and I want to run it on the sum.py script, which I know is here. Okay, and see what it does. Okay, and I get an error message which says Python 3's work fine. Okay, because the error messages come from the Python 3 command, but it tells me it can't open that file. And the reason it can't open that file is because that file is on the host system, not in the container itself. Okay, so the file it's quite light what it says. That file doesn't exist. You know, as you've seen when you start up the container, if you went into it interactively, the files from the host system on the data from the host system isn't there. Okay, so you see an error such as this. So that's what I've just explained there, right? Is the error message means that the data is not there. Now, in order to use the Python, which is inside the container, and the script, which is on the host system, we need to create a link between the directory on our computer and the place in the container. This is called a mount. Okay, so we're going to mount our directory from the host system to a location in the container so that the things that are inside the container can see the data as if they were on the host system. And the way we do this is we use an additional option to Docker run, and it's the -b option. And it takes two bits of information. It takes the location of the directory on the host system, which here is represented by this $pwd, and the location to mount it to in the container. These are just paths in the same way as any directory is a path. You know, so my directory here is this long path. Okay, so if I do Docker run again, I'm going to add this new option. So -b. So this $pwd just uses a well-defined environment variable, which is essentially represents print working directory, which means this current working directory I'm in. So it means this one. I could have just as easily, I think, said either this full absolute path here, which has been a bit tedious to type, but I could have copied and pasted it. I haven't tested this, but I might also be able to use dot to represent the current directory. I suspect that would work. But $pwd is what it says in the course, so let's use that. The reason for that, sorry, before I run it, let me just show you what's in that what's in that. This is just an environment variable that contains the current location. Okay, so there's nothing really magic there. So let's add this option in. So it's -b to create a mount. We're going to, on the host system, the directory we want to mount is this current directory, and in the container we're going to mount it at /temp. Okay, let's try that again. Okay, so we still get the error. So the error this time, the reason, of course, is that sum.py isn't. We need to specify where that is within the container, so the container run command. Okay, and because we've mounted the local working directory at temp, we need to precede sum.py with the temp. Okay, so this is the full path to the script within the container, because the local directory has been mounted at /temp. Now I know it's a little bit tricky to explain in words, but hopefully you can see what's going on here. If it isn't clear, please tell me. I'm happy to go over it again. Essentially, this is the path within the container, and we're making that path by mapping the current directory in the host into this location in the container. So let's try running that. Hopefully it'll work this time. Okay, it says sum 0. That's because I haven't given it any arguments, so the sum is 0. I haven't given it anything to add together. Okay, so this our Docker command's getting a bit more complicated now. So we've got Docker run, we've got the mounting command, we've got the name of the image we want to use, we've got the command we want to run when we're in the container. Okay, so what we've now managed to do is make the data available from the host available within the container, so we can actually use the tools we've installed in the container to operate on that data. Right? And this is a key thing, right? Because without this ability to access data outside from outside the container, then there's only very limited things we can actually do with a container. Okay. There are some other commonly used Docker. I'm not going to go over these other commonly used flags. Just about setting working directories and stuff like that. If you want to, and the user flag, you can look those up and play around with them if you want. So now, why don't you try? So we know the Python 3 script. You saw up here that if I use it to add two numbers together, it should give the sum equals 3. Have a go at doing that, but with the container instead, and see what that gives. I'll just give you a minute or so to have a go at that and see what you think and what that gives. And depending on what output you get, have a think about what that means, and can you understand what's going on. Also, if anybody's got any questions at these points or they're unclear about the mounting thing, please do tell me, because it is a bit odd to get your head around about trying to imagine things on the host and things in the container and trying to keep track of the two of them at the same time in your head. So Jacob, so there's a dollar sign missing from before your PWD by the looks of it there. And I think it needs to be capital PWD as well, though I'm not 100%, I'm not as sure on PowerShell, but I think it needs to be capital PWD, and it definitely needs a dollar before the curly brace. So does Docker have problems with spaces with spaces in the working directory? Potentially yes, because Linux doesn't like spaces in file names, really. I mean, yeah. I mean, generally, I would say, I think best practice is to avoid spaces at all times in directory names or file names. Just in general, in whatever operating system you're working on, it makes things easier and potentially moves a lot of problems further down the line, because spaces can cause issues. Yeah, you could try. I mean, let's try it. In fact, right. See, it's even hard to get into it, isn't it? Okay, so the quotations work. Okay, that's fine. So I think that's probably because it's expanding the PWD, and that introduces a space into the Docker command, and it's trying to interpret. It uses spaces delimiters between the bits sections of the Docker command, and that's what's causing the problems. Okay, fine. So the quotations work. That's good. So let's go back to Docker intro. Yes, I think that's right. So let's try and run this again, but with the numbers on the end. And it just worked fine. Okay, so and as I've said, our Docker commands got quite long, and we went through it. I did mention we went through it. So actually, I won't do this exercise again. But there's the Docker run container, a bit about the working directory, the name of the image. So this is a typo in the lesson here. That should be image, or the container image, and what commands to run in the container. So almost all Docker commands have this form. Docker, the action you want to perform, the options, the image name, and the command, or whatever you want to do with it. So you can also, of course, mount the the directory still and just run it, have an interactive run in there. I need -sh. Of course, I need the -it again there, which is the same as -i -t. And that gives you a command there, a prompt in the container, and we mounted it at /tmp in here, so you can see this includes the contents of my directory. In fact, if I create a file here, I've created a file there. When I exit my container, of course the file's there, because that directory was the directory on the host. So anything I do in the container in a directory that's on the host actually really affects what's here on the host. Okay, so I can get rid of that and tidy up after myself. So mounting the folder is very useful, or the directory is very useful when you want to run the software inside the container on many different input files. Now, sometimes you might want to actually encapsulate the data itself into the container permanently. So say you created a Python script and you didn't really want to have to distribute the image and then the Python script as well when you were sharing the container with people and then provide instructions on how to run it. What you could do instead is put that Python script within the container image. So when people get the image, they automatically get the script you've written as well, which in some sense is the canonical write script. And by people here, of course, we have to remember all the time that one of the people I'm referring to is your future self in a year down the line where you can't remember what you did and which version of the script you used. If you've built the script into the image itself, then you've got a definitive copy of what you did at the time. So it can often be very good practice in terms of reproducibility and enabling that. And so we can do that. The way we can do that is within our Dockerfile using an additional keyword such as copy, which can copy data from the host into the image when we build it. Okay, so that then it doesn't depend on you mounting a directory in the image, because it will always be there because it was built it was copied in at build time. Okay, so we're going to add a new line to the Dockerfile we've been using so far to cover sub.py. So what I'm actually going to do, because the Dockerfile in this sum directory, the Dockerfile in the sum directory is the one without the commands. I'm just going to copy the one from basic to here, so I can start from modifying it rather than having to type everything out instead. So this was our original Dockerfile. Okay, and this time, as well as the run commands, we're going to use the copy keyword to copy the sum.py script actually into the container itself. So let's do that. So I'm going to add it here, copy sum.py, and then I tell it where I want it to go in the container image. So here, because there's no real home file systems, there's no users, I'm just going to put it in /home. So its path, its full path in the container would be, I'll take it here for a minute, but I'm going to get rid of this in a moment, would be /home sum.py. Okay, because I've copied it from the current working directory on my host into the container image when I build it. So let me get rid of that bit. Okay, so we're doing exactly the same. The only thing we're doing is adding in this copy. So let's try that. Let's try making, building that image in the same way as we did before. So we do Docker build. We're going to give it a name. I'm going to use my, oops, I can't even spell my name. My Docker Hub username. I'm going to give it a different image name this time. Instead of Alpine Python, I'm going to put Alpine Sum. And the bit I always forget, the location, the directory the Docker file's in, which is this directory here. Let's try that. Okay, so this time it did the normal stuff we did before, which you'd seen before. It started from Alpine. It ran this installation command, and then you can see it did the next thing. It copied sum.py to /home. Okay, so did it work? Okay, so you remember how to run the container interactively. Try it with your new container. Try running the Python script in the container and have a go and see it. So I'll give you maybe 5 minutes for that one to try to build the container and then try and get an interactive shell in the container and make sure you can actually run that script successfully. Okay. Hopefully people have been able to have a chance to have at least a bit of a go at that. So let me try running the container. So in this case, we want Docker run -it because it's interactive. The name of the container itself. Alpine Sum. And to get an interactive session, we use SSH because it's Alpine based. Okay, so we should find that we've got Python 3 installed, hopefully. Perfect. And if you remember, we copied the file into /home. Oops, and there it is, sum.py. So if we do Python 3 home sum.py, then we can use it to add up two numbers. Now, notice that in this Docker run command I ran here, there was no mounting of host file systems into the container. Okay, so everything has to pre-exist in the container, but this sum.py script now has been copied in at build time. So whenever the image gets distributed, whenever someone runs a container based on this image, they will always have this script available in the container, whether they mount externally or not. So I'm just going to exit the container there. Okay. So this copy keyword we use to place your own scripts, but not just scripts. Obviously, you could put in static data that you want to publish. You know, things that may be key to the workflow and really important. You know, if the scripts change, you know, this was a question we had before about, you know, related to sort of, you know, what should the default command be? But it depends how the container is being used. If the container is just a utility to do one thing, and it does that one thing, that one script that doesn't change all the time, then that's fine. Build the script in. But if it's a general purpose container, you're going to be doing lots of different tasks with it, then it may be that you don't really want to copy in the scripts because they'll change a lot of the time. The other thing, if you put a lot of data in, ticket scripts aren't really a problem usually because they're really small text files. But if you're putting a lot of data in, then that makes the size of the image larger. It takes it longer to download and makes it harder to manipulate for people. So there is always a trade-off between what you want to do. You know, so putting like, I don't know, a petabyte of data in a container is possibly not the best thing to do in the world, for example. And other alternatives, you can get images into your so you can get the data into your image in other ways. Say your script was on the internet somewhere, of course you could use the run command and then either use git clone to get something from a repository straight in. Now of course that means that it's baked into the image, that version that you cloned from the repository at that point. So when the repository updates, of course the image isn't updated automatically. You know, it's a snapshot in time, but that's obviously one of the desirable things, or what can be one of the desirable things around containers, is you get that exact snapshot of what you did at that time. So that's probably a positive rather than negative. Of course, you could also use wget. Excuse me, as long as wget's available in the container from the in the container image, sorry, that you're using. So I don't know if it's an Alpine or not. Okay, so it is an Alpine. So wget's there already. So when you actually build the container, you can use wget to get the container. So to get the data into the container in that way. And that's what it says there. You know, they've got to be in the distribution. So at the bottom of this episode here, there are some extra Dockerfile options which you can look at. One thing I do want to talk about here is this first option here. So you may say, you know, we've talked a bit about what the default command is. Okay, so and at the moment our default command is to run Python 3 you know, minus version. And so, sorry. But you know, actually, if we're building a script in, maybe we want the default command to be the script itself. So we could change the Dockerfile to do this. So let me edit my Dockerfile again. And I'm going to change the command this time. We're going to be Python 3. But this time we can run home sum.py. Okay, so we built the script in. And we made the default command. So that sounds much more useful. Okay, so and somebody asked about tagging. So this time we're going to do the Docker build again. But instead of being latest, I'm just going to, because this is a test one, I can give this one a tag v1 to distinguish it from the one we built last time, which had the automatic tag of latest on, just to try and organize things a bit more, or because I know this one's different. So let's do that. Okay, so it's created a new image for me. So if I do Docker run and then use the new image I've created with the v1 at the end, the default command should be sum. Excellent. So if we don't give it any arguments, it just returns sum 0. That's exactly what we expect the script to do with no arguments. So now we can try and add some numbers together with it. Oh, and this time it doesn't work. Okay, and this looks like the error actually that somebody already saw and posted in the chat, which this sort of error, this OCI runtime create failed is essentially I didn't understand the Docker run command, is what it's saying there. And it says exec1, I don't understand. And the reason here, the reason for this is can you remember the syntax of a Docker command? Docker run in particular. Docker run, name of the container, command to run. So here it's trying to interpret this one as a command to run. And it's saying, actually, I don't know a command called one. I don't know what to do with that. So it's crashing. Okay, and that's what that's this error you see here. Okay, because they're trying to replace. To have a command that always runs when the containers run and can be passed arguments given the command line, actually you don't use the command thing in the Docker file. You use the word use the entry point keyword instead. Okay, so instead of defining the command, we define an entry point which runs the command, and then we specify the command as some set of default arguments to pass instead. So let's edit this Docker file again, because so this changes to this changes to entry point, okay, which does something slightly different from the command, and then command becomes a default set of arguments. You don't have to have a default set if you don't want to, but let's set a default set of 10 and 11. Okay. Yeah. So if I regenerate the image, I can overwrite this name in the image, and the other one becomes an orphan. And as Jeremy said, it doesn't die and go away. It just gets it's left dangling in some sense. So let me try and build this one again. Okay, so I've done something different this time, and now I can run this one again. Now, of course, if I run it with no arguments, the sum's 21 because the default arguments are 10 and 11. And now if you supply 1 and 2 instead, I get the sum is 3. Okay, so that gives you a recipe for how you get to a place where you can have a container that now becomes essentially an alias to a command. So for example, in my shell, I could do alias sum num, sums numbers. So now I can just type sum num, and it gives me 21. Oops, 12. Okay, and I've created my own command, but with a specific versions of sets of software inside it, and that will always do the same thing and is defined closely by is properly defined by the Docker and by the by the container image and the Dockerfile that built it. Okay, so you can see how you can start to build up suites of tools and workflows based on well-defined building blocks, the container images that you've built yourself. Okay. Now the problem becomes, of course, if you want to run an interactive command, if you specify the entry point, using the shell interactively becomes difficult. So you have to use a slightly different incantation to Docker to get to an interactive shell instead of the what we've done before with the IT and then specify the command. Because you've created the entry point, you actually have to overwrite the entry point of bin this time instead to get an interactive shell on the command. There are a couple. There's one more slightly extra example. I'm not going to go through here. You feel free to have a look at it. Feel free to ask questions, but it just sets up the container so that you can add the script into the path to run it directly. But that's not particularly interesting to us here. So Where are we up to? Okay, so we're up to another break for 50 minutes or so. I think that's pretty good timing, actually. So before we go on break, has anybody got any more questions about data in container? Because that section was called Advanced Container Building, but that's not really what it was about. What it really was about how you make data accessible within containers, either at build time, which we saw at the end, or at runtime by mounting. What questions do people have on that? Is there anything that I need to clarify? No. So either I put everybody to sleep with the sheer tediousness of building Docker images. So the path bit at the end, the instructions is written, leave you with errors. So I'm happy to look at the errors. Okay, so fine. We can have a look at the path bit, and I can double check that works. I can do that over the break, Chris, and get back to you. In terms of Matthew's question, it says, if I write a file using the container, I assume on a host direction mounted within the container, will those files belong to my user, or somehow the container uses default? Okay, so the answer here is a little bit, it's complicated. Well, except that if you're using Mac or Windows, it's not complicated because the Docker desktop sorts all that out for you. So if you do it in Docker desktop on Mac or Windows, you'll find that the files will belong to the user that you are on the host. Okay. Now, if you do it on, and Jeremy's probably going to correct me here because he's more in favor of the Linux stuff than I am. If you do it on the Linux, you can end up with just the files being owned by root rather than being owned by the user. And there's an option, I think, or there's a way of setting up Docker so it fixes that on Linux. Is that true, Jeremy? Are you still there?
Yeah, I think that's basically the case. There is a way to map the users. It's a little bit nasty the way you have to do it, but yeah, if you just run a Docker container on Linux, as Andy says, you will get into that as the root user, and when you create files, the permissions of those files are the files are owned by root. But there is a way that you can effectively map your user on the host system into the container. I can double check how to do that and provide some information. But yeah, otherwise that can cause a problem. So basically, yeah, if you create a file in a in a bound directory in your container, then when you drop out back to your user, you might find you don't have access to the file because it's owned by root. But there is a way to address that. I will double check and put something in the chat in a moment.
Okay. No, it's the -u option, I think.
Yeah, it is it is the -u option. I can't remember exactly what the syntax is.
I can't quite remember the incantation, but
yeah, sorry, the message I put in the chat was not related to that. It was just a previous message that I had discussing that. I will check it out. And,
yeah. No, we can look that up over the break. I'd get back to you. It is a bit messy, I seem to remember. I seem to remember it's not the nicest syntax, and it feels like a bit of a hack when you do it. Thanks for those questions. We'll have a look into the path that Chris was having problems with, and the getting the ownership correct for Linux users of Docker as well. And we'll aim to start back here at 3:05, so that should give you just under 15 minutes to go and get some refreshment. And then after 3:05, we're going to look at okay, we'll do a quick example of using some containers in practice with a real-world example, which isn't very researchy, but is useful to show the power of containers. And then we'll talk about reproducibility and archiving and those sorts of things as well. Fine. Thank you, Michael. That was a useful answer. So I'll see you at 3:05.
So there's a question there in the chat about how you would use the Python container from the Docker Hub instead of installing Python in the container. So you can actually just go and find one of the. I mean, there are probably large numbers of Python containers on Docker Hub, but let me just put the link. I think Andy had it earlier in the. Yeah, you can just do a search, but there are the Python kind of official containers on Docker Hub, which I think Andy had the link for them before. Let me just put those in the chat. So yeah, you can, as Michael says, you can do a search, but that link I've just put in the chat is the link to the Python official containers, and you can just pick a tag from the list. Sorry, go ahead.
Yeah, I was just you should be able to see it on my screen there. Sorry, I neglected to switch my mic back on, but it's on the Docker Hub. It's just called Python, and it actually, Andrew, it is as simple as Docker pull Python. Right, that gets you that container with Python installed, and the default entry point is Python. Okay, so if I did, so the sum.py one's still here. So if I do docker run -v $pwd /temp Python /temp sum.py. Hopefully, it tells me it can't find Python locally, so it should go and download it. Python image is quite big compared to other ones, so it'll take a little while to get it. But there's a Python Slim, I think, as well. Thanks, Chris, for spotting that error. We'll get the material updated and fix that, because that shouldn't be there. Almost there. Oh, and it didn't work because I did something very silly. Did I not? So this is the problem of trying to do examples on the fly, right? I wonder if I actually need, do I need that? Yes, sorry. Okay, so the entry point wasn't defined as Python, was the problem with my command, which I thought it was. Okay, so you can just, if I'd actually stopped to read the documentation, I'm sure I would have realized that. Yeah, so yeah. Okay, so if you look at the examples, they say you have to specify Python anyway. Yeah, it's not home. So sorry, Mark, is this for using the one I've just tried to show and failed and then worked, or for something else? It's in, because I mounted it at temp. It's only home where we copied it into the image using the docker build command, using the copy command in the Dockerfile. No, sorry. Sorry, I said back at 5 past, because we're slightly ahead of schedule. You know, I think it would give people. I think there's often quite a bit of discussion after the bit about reproducibility. So we'll start slightly ahead of schedule. That gives more time for discussion, which people are interested in. Okay, so I think we've covered just about, most of the sort of technical material here in at least of day one around Docker and using containers. So we talked about running and managing the images and containers, and this afternoon we talk more about building containers, building images, and the different ways of doing that, and including data and accessing data in the images. So the one last thing I wanted to show you was some sort of use of Docker containers in practice. Now, there's a couple of examples here that we have in this section, one based around Jekyll and one based around GitHub Actions. And neither of them are particularly researchy. I'm going to look at the Jekyll one for the moment because I think there's less context to explain around it, and you can see what happens. And I understand that this isn't particularly a thing that's associated with research. And you know, if after using the Docker containers for a while, you think you've got a really good example that would fit in this section that shows how to use research, that shows how to use containers and demonstrate it in the research context, then we'd be super happy to hear from you to add it into the lesson, because the more different types of examples, the better. But the Jekyll one's quite nice, actually. So I'm going to follow this here. So some of you may be aware and have heard of GitHub Pages. So you can use, within GitHub, you can host a Git repository there. And that repository or part of that repository can automatically be transformed into a website by GitHub Pages and then hosted on the internet. In fact, if you look at the top of the URL for this lesson, it is hosted on GitHub Pages. So the this lesson is actually a GitHub repository that's automatically turned into a rendered website that you see by GitHub Pages. Now, the technology that GitHub Pages uses under the hood to do this is a thing called Jekyll. And Jekyll takes static text in whatever format. It could be in HTML, or most of this lesson is actually written in something called Markdown, and then turns it into a website with all the formatting and links that you see here based on that. Now, I mentioned, I think, right back at the start that Jekyll itself, while really useful and really powerful tool, and it obviously underpins GitHub Pages, is a real pain in the neck to install on any system. This is partially because it depends on Ruby, and Ruby itself has a lot of dependencies. And then on top of the normal Ruby dependencies, there's all the dependencies for Jekyll. And I've just really had very hit or miss experiences with getting it to run on Mac, on Windows, on various things like that. But there is an official Jekyll Docker container out there on Docker Hub, which you can then use to short circuit all this and not have to worry about the installation. And what we've learned so far throughout this lesson gives you enough information to be able to use that and to make use of that Docker container and to render this website yourself on your local system. So, and what we're actually going to do is get a copy of the source for this website and then use the Jekyll Docker image to render it locally on our whatever your host system is. Mine is a laptop, so we could view it. And what we use this for in practice, and really when developing the lesson, is you can have this thing running in the background, and as you make changes to the pages, it automatically re-renders the website for you. So you can do all those things without having to push them up to GitHub, wait for it to be rendered on GitHub Pages, and do that sort of stuff when you're developing the lesson materials. So the way we're going to do this is the first step is we're going to go to the GitHub repository. I'm going to follow this link. And this gets you not actually to the one we're using today, but actually the root lesson for this, which is in Carpentry's Incubated Docker Introduction. So it's slightly different. But what I'm going to do here, is download the zip file. So when we go onto a GitHub repository like this, you should be able to see here. It's a bit small actually. Let me make it a bit bigger. Okay. Hope you can see that there's a big green code button, and if you click on that, it gives you a menu, and right at the bottom there's a download zip, and that's what we're going to do here. Okay, so I'm going to download this zip file, which is called Docker Introduction -ghpages.zip. So I'm going to move up to the main Docker intro directory. I'm going to copy it across from my downloads folder, because I just Docker introduction zip and it's a dot. Okay, and it's there now. So let's go back here. I've got the downloaded zip file, and then I'm going to unzip this source. So let's get it unzip. And you'll see I've created this directory called Docker instruction Github Pages, and this contains all the source for this lesson that we're running at. Okay, running. And now, so that's where we are now. So you can now request that we create a container that compiles these files into the lesson website. Okay, and we're going to use Docker to do this. So let's have a look at the Docker command here. So most of these things we've seen before. So we've got Docker run, our standard thing to run a container from an image. The --rm option we've discussed, that deletes the container as soon as it's exited. Okay, minus IT makes it an interactive container. Even though we're not going to create a shell in this, we want this one to be interactive because of the way the Jekyll tool works. The -v option, as you've seen before, is going to mount the current working directory, which contains all the source for this website, into the directory in the container of /srv/Jekyll. Okay, let's just ignore. I'll just ignore this one for a minute. I'll come back to it, the -p one. Then we give it the name of the image on Docker Hub that we want to run, which is Jekyll/Jekyll Pages, which is the GitHub Pages, the current GitHub Pages version of Jekyll. And then the Jekyll command to actually run the website, to compile and display the website locally, which is Jekyll serve. Okay. The only new option we've got here is this one, this -p. 127.0.0.1.4000. What this is doing is mapping the port and the address that the website's being served on in the container to a port on an address on our host system, so we can view it within a web browser on our host system. So this actually just says map port 4000 in the container to 127.0.0.1 short is the address of the local host. That's the local display. It's port 4000 on our system, on our host system. Okay, so let's take that whole command, which is quite a complicated command, but we understand most of the bits of it because we've worked with them before. And let's see what happens if I try and run that. So first of all, it tells me it can't find that image locally. So then it goes and gets it. This is it pulling all the layers as it usually does. We've seen this before. And extracting the layers. Okay, and somebody asked before about versions of images for different platforms. Now you can see here, I said they might see it later. You can see the requested images platform, which is AMD64, which is x86-64 system, doesn't match my host platform, which is ARM64v8. Okay, and I didn't revert, so it's warning me there that it's pulled an image which is x86, but I'm not on x86 system. Now, on a Mac, that doesn't matter because it has this thing underlying it called Rosetta, which automatically translates x86 instructions into ARM instructions, so it can still work. Okay, so that's not a problem. When we looked on some of the other images, you didn't see this because they did provide ARM images. So by default, it was pulling the ARM64v8 images, which is why I didn't see that warning. But in this case, they haven't got an ARM image, so it just has to run the x86 one. So actually, so this is all done. So it's pulled down all the Jekyll stuff, and this is actually Jekyll running itself here. It tells me that the config file is this, and this is the config file from our source, and various bits and pieces. The final thing is the server address that tells me it's serving on. So I can copy this web address, hopefully, into my web browser on my local system. Let me get rid of that download down there. And let's see what happens. So you can see it's rendered. This is a rendered website of the source that we've got locally downloaded to our system. It's not getting this from the web. It's actually just doing it all from within the Docker container on our system. And you'll see that actually it looks a little bit different from the one you have for the lesson we're actually following, because we've added the site-specific information, the little customizations and things like that. And this is the vanilla lesson itself. Okay, so so I know it's not really a research application and the way of doing it, but what it hopefully shows you that I went from it less than 5 minutes to having Jekyll working on my system. And certainly my previous experience of trying to get Jekyll working natively by using the standard Jekyll install procedures is that there's hours of work there. Okay. So one of the things I like about this example, it shows how powerful, containers can be in short-circuiting and giving you the opportunity to actually go and do something, do the thing you want to do rather than fiddling about with software, which is not the thing you want to be doing. In this case, the work I want to get on with is developing the lesson and improving the lesson. And I could do this rather than having to schedule a boarding of my time and trying to get Jekyll working in the first place so I could actually then start fiddling about with the lesson and do the things I want to do. And for me, this is one of the most convenient and most powerful features of Docker, as well as all the research stuff, which we'll talk about in a moment around reproducibility and those sort of things. So this is a very practical thing, but hopefully it illustrates what we can, how it can be used. Now, so that got the Jekyll thing up and running, and it says there we can press Control-C to stop. Let's try that. Sometimes that does work, sometimes it doesn't. Within the container, the Control-C is not working here, so I'm going to have to stop the container manually. So I could do that on my Mac by starting up the Docker dashboard. So I'll just click that. It'll take a moment to come up. Hopefully it's come from the wrong window, so I can show it over here. This has a list of all my running containers. So here's the Jekyll one up here that I couldn't kill with Control-C, but it does have a stop button, so I can just stop it there, hopefully. And it will just take a moment, hopefully, to stop. And I should get my prompt back. Yeah, there we go. Okay, so I'll just get rid of the dashboard now. So it stopped, and I got my command prompt back. And I could have changed these files and worked all out, including the lesson, that sort of stuff. Now, the final section of this course is to talk about the reproducibility aspects, and I'll go on to that now. But I just want to check before we go there: are there any questions, or do people have anything they want clarified around the sort of technical aspects and the running of Docker before we talk about the reproducibility aspects, which is a bit more of it's less technical, more hand wavy sort of argument? Is there anything you want me to go over again before I start that section? No, I'm hearing definite sounds. So it may be that, like again, once again, it could be that everybody's asleep, or it could be that people feel like they've got a good idea. One thing I would say is that if you do have questions, and questions often occur to people after they've been, after you've been on the course, please feel free to get in touch. You can get in touch with me directly via my email address. It should be there on the course website, or you can email the Archer service desk, or any of the contact email addresses you've had access to, and they will come through to us. So if you think of any other questions afterwards, or there's something you want clarified or you didn't quite understand, then please get in touch. If we can do it via email, great. If not, then we can arrange a session to have a chat, and that's no problem whatsoever. With saying that, let's go on and look at the reproducibility aspects, because we've talked a lot about Docker so far in this lesson, and the technical aspects of running Docker, but the lesson is called reproducible computational environments, using, oops, sorry, I've gone the wrong way. Let me go back. Reproducible computational environments using containers. And we haven't really talked very much about reproducibility. I mean, we mentioned it a bit at the start when we were talking about the reasons for using Docker and containers and things like that, but we haven't really delved into any sort of detail. So that's what I want to cover in this sort of final section, is some of those aspects. One thing I want to note, first of all, though, is that these sorts of reproducibility aspects of software containers are really a very active area of research at the moment, and discussion and development. So, they will be subjects of many changes going forward, and new best practice will emerge as time goes on. We're going to present some ideas and approaches here, which I think will stand you in good stead no matter how things move on, because actually what you really want to do here is not so much have a set way of doing things, but have an understanding of the sort of issues you want to think about, and how they might impact the decisions you make and how you use containers around your research and around your work. So, think of this as less as a recipe, but more a sort of, here's some areas that you should be actively considering when you're working in this sort of way. But before we start, I think we need to define what we mean by reproducibility here. So what we actually mean is the ability of someone else, and as I keep mentioning, this is often you, your future self, being able to reproduce what you did computationally at a particular time, be it research, analysis, whatever, as close as possible, even if you don't have access to the same hardware resources you did when you did the original work. And the reason, hopefully by now you can see why the containers might be an attractive bit of technology to help with that. Because the same computational work or the same work or analysis work could be run across multiple different technologies. You can save the exact process you used from your computational work rather than relying, because it's contained within, say, the Dockerfile, or by tying things together with scripts and things like that, rather than relying on potentially incomplete notes. You can save the exact versions of software, the dependencies in the image, so you can keep that image set up in exactly the same way as it was when you originally did the work. You may be able to access legacy versions of the software and the underlying dependencies. They may not be out there anymore. They may have been removed off websites and may be difficult to get hold of. But as long as you still have the image and potentially the Dockerfile and any install media that you built into the Dockerfile, then you can still work with it. Depending on size, which we've discussed already, you may be able to also potentially able to store a copy of any really key sorts of particularly static data in the image, data that feeds into some sort of analysis that doesn't change, parameters and such like, and those sort of things. And you can archive and share the image, as well as associating a persistent identifier of the image to allow other researchers to reproduce and build on your work. So because it's a digital asset, you can add a DOI to it in the same way as you would any other bit of data, or even a paper or things like that. So that allows people to cite your work. You get credit for the work you've done. And also helps with reproducibility, because people know exactly what you did. They can look at the image that you used and what that means. So in terms of sharing images, the Docker Hub, you've already seen, provides a platform for sharing images publicly. Once you've uploaded it, you can point people to it, a location, they can download it, build upon it, or reuse it. And it's actually fine. I mean, that's a really useful way to use it. It works collaboratively with images, with people on a day-to-day basis, but it's not really a good option for long-term archive because in support of research and publications, because for a few reasons. One is free accounts have a limit on Docker Hub in particular, maybe not on other platforms, but certainly on Docker Hub, have a limit on how long an image will be hosted if it's not updated. So if you put an image there and nothing happens to it, which is what the definition of an archived image is, then eventually it will just get deleted from Docker, because they think it's not under active development anymore. There's not a straightforward way to associate persistent identifier with an image, a DOI, that says this is the exact version that I used. And you can easily overwrite a tagged image with a new version by mistake. We've seen that before. I can recreate images with the same tag over and over again, and the ones that originally had that tag just become orphaned. And if I push to Docker Hub, it's just going to overwrite the previous version that was there. So then it becomes incumbent on me to keep track of tags and be very disciplined about it. Whereas if you use a proper archiving service, as soon as you put something up there properly, it can't be overwritten, because that is the copy, the snapshot, the archive as it is. And if you upload another one, it gets another identifier because it's another snapshot, another archive. And one service that's very popular for doing these sorts of things is very generally useful is Zenodo, which I think came out of CERN, the particle physics lab in France and Switzerland. It's a service that allows you to publish data or various digital artifacts and create an identifier a persistent identifier allows you to identify that digital artifact you've updated, and it should be essentially it's immutable as well. Once it's there and it's been created, it can't be overwritten. You write something else, it gets a new identifier, and so Zenodo provides this functionality generally for free as well. So one of the things that Zenodo supports is the archiving tar images, and Docker images, as well as being pushed to Docker Hub, can be exported as a tar archive, which you can then use and upload and archive on Zenodo. So, for example, you can use the Docker save command to take one of your images and output it as a tar archive. So the problem, one of the challenges is, of course, that your images can become quite large. Zenodo supports uploads up to 50 gig. So you may also need to compress your archive to make it fit on Zenodo using something like gzip or zip also, of course. If it's larger than that, you may have to explore other options. Sometimes local institutions have their own services for archiving data associated with particular associated persistent identifier with it and making it available to people. For example, in Edinburgh, we have the data share service, which fulfills many of the same functions as Zenodo, but potentially can be set up to support bigger artifacts. Of course, you may need to pay a lot of research grant to make that happen. So once you've done that and you've archived it, so let's have an actual go about doing this. Let's see how big this Python image is and have a go at uploading it to GitHub. So let me go back down. I'm going to go in the sum because that's where we're working, and I'm going to go Docker save, and it's 8 Turner EPCC Alpine sum. I'm just going to take the v1. I know I saved one like that, and I'm going to save it as Alpine sum at v1.tar. So hopefully that should do it, and let's have a look at how big it is. Okay, so it's this image here, so it's 132 megabytes. So it's well within the size of 50 gigabytes for an upload to Zenodo, but good practice, let's make it a bit smaller. Let's see how much smaller we can make it. gzip. Okay, so that's taking it down to 50 megabytes. Okay, so it's more than compressed by more than 50%. So that's useful for us. Okay, and once we have our archive, you then can deposit on Zenodo, and this creates a long-time archive snapshot of your Docker image, which people, including you, can download and reuse or reproduce your work. Now, it's not integrated with Docker Hub in the same way, or a repository the same way. So you can't use the Docker pull command. Instead, you have to use the Docker load command to get it back into Docker. But that's okay. You can then push it if you're actively using it. You can push it back up to Docker Hub if you wanted to. And it creates a DOI, a digital object identifier you can use to cite it any publications or outputs to enable the reproducibility and also recognition of your work. Right, so people who reuse that image for their work or build on it can cite you properly for the work you've done. And in addition to the archive file itself, the deposit process actually provides some basic metadata to classify the images associated with it. While I talked a lot about Zenodo here, as I've said, it's not the only option. There are other ones out there, and particularly specific research areas may have their own special places for doing this sort of archiving, and you should look into them. Institutions can have their own places as well. Zenodo is a good sort of general purpose place to put these sort of things. If you want to try it out, there is without actually creating archives and feeling like you're polluting the internet by creating false DOIs, which are just playing about. Zenodo do have a sandbox, version where you can practice uploading data and tagging and getting DOIs. So you can generally add things here. So let me see if it reminds me if it knows me and knows how I log in. Let's try that. I can't remember my password, is the problem, of course. Can I log in with GitHub? That's maybe a better way to go. Ah, perfect. That worked very well. Okay, so now this is the Zenodo sandbox. So anything I do here is not real. So I'm quite happy. I can play around. I can try uploading things and see how it works. So let's try up there. So you see I've done this before. There's a test container upload there. So let's get a new upload. So I can drag and drop files or choose files. So let's go to, oops, going the wrong place. Users, my username, where was I? Was in temp, I think. Containers course, Docker intro, some. There's my user file. Okay, so it's quite happy with the size and the thing. You can associate, some communities have access things here that you could associate the upload with. I think I have a feeling there's an ARCHER2 community, but can I find it? I don't think so. No, okay, fine. I'll leave that for the moment, but you could add it to a community if that exists. You can say what type of upload it is. In this case, it's probably software, or you could choose other Docker image ones, but really it's probably software. You can specify it if you've already got a DOI, but if you haven't, it will create one for you. Create publicity date, container upload, July 2021, and then you can put in all your authors and stuff like that, a bit of a description. These are the sort of things that ask you for access rights, and as you go through, you can eventually publish this, and it will generate a DOI to go along with the thing you've uploaded. I just realized, of course, that that's very small, so you can't see it very well. Let me make it a bit bigger. Okay, but once you've selected your file, you can do it and have a look at it. So let me go back, and I can show you in true Peter fashion. One I presented, here's one I did earlier. So that was a container.tar software. It's generated a DOI for it. It's not real on that. That was when it was deleted. I put my authors in and test upload in the description, all the bits and pieces that are needed, and then you can add it in. And then once you have that, there's this permanent record then on Zenodo with the DOI. You can always go to, you can always find the thing you did, and it should be in the exact state that you used it when you generated the results. Okay, so that's a bit of a chat about archiving and how you might do that, particularly around Zenodo, and that's one part of reproducibility, the sort of mechanical bit of how you make something available. But there's a more sort of what's the right word to do it? There's a more sort of good practice, you know, to making decisions and management of images and how you use containers that's worth thinking about as well. So there's some good practice ideas listed here, you know, making use of images to capture the computational environment you required for your work. The next one's interesting, which is we mentioned it before, is but deciding on the appropriate granularity for the images you use for your computational work. You know, this will be different generally for each project or area. You know, one thing I'd say here is that take note of accepted practice from temporary work in the same area. If anybody else is using containers in the same sort of area, look at what they've done and sort of have a critical think about, well, does that match what I'm doing? Is that a good idea? Has that worked well? And can I adopt that approach? You know, think about what the right building blocks for individual images are in your work. We'll talk a bit more about this granularity one point in a moment, because it is a reasonably important one. Document what you've done and why. You know, this could be comments in the Docker file and use the and the use of the image in describing the associated documentation and or publications. Make sure references are made in both directions. So the image and the documentation appropriately linked, right? So if you've written a paper, it should be linked to the image. The image should also be linked to the paper in some sense to say that it was used there. And you know, when you publish your work in whatever way, using an archiving and DOI service such as Zenodo, make sure its image captured as it was used for the work, and that it obtains a persistent DOI type cited and referenced properly. You know, these are the key, some of the key things to think about and make sure it happens. But you know, I think The granularity section, which is what we're going to talk about in a moment, is really I would characterize as thinking before you act, right? And it's thinking about what you want to do and why you want to do it that way before you start doing it, and before you've invested too much effort down a pathway that then becomes unsustainable. If you want some more information, the Code Refinery people have a useful overview of data sharing, and it also gives you some extra links to services to use where you can share data such as container images as well, including Zenodo and others. So if you want to read a bit more about data sharing and FAIR principles and all those sort of things, then that's a useful place to start, is that Code Refinery link there. But one of the key decisions you may need to make when containerizing research workflows is what level of granularity you wish to employ. So to characterize what I mean by granularity here, the two extremes are creating a single container image with all the tools you require for your research analysis or workflow, one big monolithic thing, that you can then use to do your research. Or at the opposite end, creating many container images, each running a single command or step of the workflow, and using them in some sort of sequence. And of course, any real application sits somewhere between these two extremes, and it depends a bit on what already exists as well. If you're building on top of images that already exist, then what is there and ready for you to use, and what granularity that has obviously has a bearing on how you do this. And there's an exercise here thinking about the advantages and disadvantages. I'm not going to ask you to go through and do the exercise, but we will run through what they are a bit to give you an idea about them. But there's no hard and fast rules here, and thinking. I think the main thing I'm trying to push here is thinking ahead and doing some planning before you jump into doing this in practice in your research, is thinking about what is the correct granularity and why. Okay, maybe that's a very simple exercise for you. That's great, but maybe it's much more complicated, and you might have to go and speak to other people about it and find out what other people have done before. So in terms of those two extreme examples, the single large container and the multiple smaller container images. For the single large container, some of the potential advantages there, and you may be able to think of more advantages and disadvantages than these, are things like it may be simpler to document. Okay, it's just very easy to write what you do with that one container image and how it's used. The full set of requirements are packaged in one place. Everything's there. There's no chance of things getting separated or getting lost. It's potentially easier to maintain because you don't have people working at odds, though the opposite could also be argued to be true. But disadvantages, for example, are it can get very large in size, making it more difficult to distribute and work with and to update in the future or to build on. You can use some techniques to decrease the sizes, such as multi-stage builds. Both Singularity and Docker support these things. One problem you might end up with is back in the same dependency conflict issues that we highlighted at the start, because you've got maybe say 2 or 3 tools within the container, maybe even more. They may have conflicting dependencies, and you're back in the dependency issue you had in the first place, installing on your local system. So you might end up negating some of the advantages of using containers. Potentially more complex to test as well, and potentially less reusable for different but related work. So there's some of the things around the large container. For multiple smaller containers, some of the advantages are obviously the opposite of what we talked about for the larger container. So individual components can be reused, making for different or related work. So say you've built a subset of tools, you could imagine putting them together in a different order or slightly different flow to do something similar but unrelated. And that often happens in research. You don't always end up where you thought you were going to end up when you started out. And the individual parts are smaller in size, make them easier to distribute. And you end up avoiding dependency issues between different pieces of software, because each of them has their own self-contained environment. So it doesn't matter that, say, one piece of software needs NumPy version 1.116, and another version needs NumPy version 1.10 or something like that. You don't have that conflict at all. and it's potentially easier to test because you can feel like the individual containers are simpler, so you can build it almost becomes like unit testing. You can test and each of the individual images is working correctly because they're much simpler on themselves, and there's less chance of these sorts of strange artifacts from things conflicting. Disadvantages could be potentially more difficult to document, potentially more difficult to maintain because you've got lots of different architects, different container images now to maintain. But that could also be a plus point if you're working with a larger distributed research group. And of course, this was written in the time when most research groups were co-located. Though there was obviously distributed work across research groups and different institutions, but actually almost all research groups have some sort of distribution in this new world with COVID. So maybe that point becomes more pertinent. What I mean here is that one person in the group could be developing on one image, and the other person could be developing on another image. It makes that quite simple. And you could end up with dependency issues between component containers if they get out of sync. If somebody's done some development and moved one of them forward, you may find that the links to the other containers don't work quite as expected. So that may be more complex to manage. But there are no hard and fast rules here. The idea is that you look at for your project, you use your experience, you maybe talk to people who've done things before in that area, potentially with containers, and at least consider it before you choose what approach to take, and think about what the right way forward is. And then there are different tools also for orchestrating containers together. So things like Kubernetes and things like this you might have heard of, which are beyond the scope of this course, but are potentially things that can help you orchestrate multiple containers working together and actually deploy multiple containers working together. Docker Swarm is one of these things. So I hope so. Has anybody got any? What questions do people have on the sort of reproducibility and the distribution and archiving containers? Does anybody have anything they want to raise, or anything that wasn't quite clear, or anything that's come to mind? Yes, sir.
So if I would like to use Docker to share kind of like the development environment for my application with my teammates, so what I would do is give my teammates the link to my Docker Hub where the Dockerfile is, and then they would like run the container in their machine and then kind of like mount the clone of the repository and then compile there inside the container. Is that how it would work? And also, is it common to keep the Docker file in the Git repository or in whatever type of global repository?
So part one in terms of question one there around the compiling. So yes, I mean that sounds like that's a perfectly valid use of a container to provide a coherent development environment that people can use to compile things. I think that's perfectly reasonable. People could use Docker pull to get hold of it, and that sounds, a pretty standard use of Docker, or no, of containers in general. In terms of putting the Docker file in a repo, that also is a really good idea. One of the advantages Docker files have is that they're text files, and that's exactly what things like Github are designed to be able to track and manage. So that's a really good way of tracking changes to the Docker file and to the image over time. And of course, there's a quite tight integration between services like Zenodo and GitHub, because if you say you get to the stage where you're writing up a piece of research or whatever it is, and people have used this particular image to develop the software, and or this release of the software was associated with this development environment. You can create then a release of the GitHub repo, which tags in time that version of the Docker file. And you could also create the image and add it to Zenodo and link the GitHub release to that image on Zenodo, so the two things are tied together. So you can say, here's a DOI that represents the image, and what place you can get the image, but that corresponds to this release. So then you can see the Dockerfile and or the repo in the state it was at exactly that release. So you have this exact correspondence between the two things, which is often one of the problems when you come to try and reproduce things, is you don't quite know what image people used or what version of the software or what compilers, those sort of things. In your scenario there, all of those things are not perfectly, because they can never be perfect, but are pretty much tied down and linked together, and so that people can always know what was done at that point in the release.
That's brilliant. Thank you.
So I think one of the things getting at in here, and that question made me realize, is that containers and Docker themselves have a lot of power in themselves technically to do things, but when you couple them with the other tooling around GitHub, Zenodo, and these things, actually you can create a pretty powerful way of understanding exactly what was done at any point in time, or what the software or what the environment looked like at any point in time. So Marco says, today we created our containers starting from a few published images. I wonder if it's possible to create a container from multiple images, so merging multiple images. The short answer to that is, I don't know. I don't know if Jeremy has any.
Is my question clear, first of all?
Yeah, no, I think I understand what you're getting at. So essentially in a Dockerfile, that would at least roughly correspond to having two from at the top.
Yeah, I'm just wondering whether there are tools to check for conflicts of dependencies between different images, and whether it's possible to merge them. It's just
I don't know. I don't know quite. It sounds a bit at odds with the Docker ethos.
Okay.
Is what I'd say, because the Docker ethos is this layering approach. So then merging becomes difficult, because where are you inserting the layer? At what point are you inserting the layers?
Well,
I think
only if there are no conflicts. But okay,
yeah.
I understand. The reason why I'm asking is because there are, of course, a lot of published images that are linked to a single piece of software. And if I want to build an environment where there are multiple pieces of software speaking with each other, that would be helpful. The other way of doing it would be to use the container individually. But then it's quite hard to share data, open ports so they can communicate together. So I don't know whether you have any advice on these two different approaches.
So I think that second approach with the multiple images talking to each other, multiple containers talking to each other, is the most. I don't know what the Docker word, the equivalent of the Docker word for Pythonic is for Python, but that is the more Docker-like approach, right? If you see, at least not in the research yet, but if you look in enterprise IT and how containers are used to build, for example, web services, that is exactly the approach that's used. You have multiple containers running that communicate via ports or by cross-mounting host file systems, or whatever you want to do, or even just piping data in between them. That is the standard Docker approach. So and if you look at these tools that coordinate containers, things like Docker Swarm and Kubernetes, that is exactly what they're designed to do, is to be able to bring up multiple containers in a coherent way and maintain the communication between them.
Are we going to cover these tools tomorrow by any chance or not?
So no, these sorts of orchestration tools are a bit beyond the scope of this course, which is really an introduction to containers. And Kubernetes and those sort of things are tutorials and lessons in their own right. So we don't really cover them here.
That's fine.
There's quite a lot of them out there. The challenge with things like these is that most of the material out there, and there's a lot of great material out there, both in terms of tutorials and lessons and things like that, is they're often not aimed at very researchy use cases. So they look like enterprise IT, building web services, building apps, those sorts of things. So sometimes it's quite hard to relate them across to research users. So there's definitely a space there to create a course that looks at those sorts of things. It's just we haven't had the chance to write it yet. certainly be interested in writing such a course, I think. But everything's time related, obviously. But I do think that's a really interesting course to write, is container orchestration from a research viewpoint. So Nicholas asks, out of curiosity, are there initiatives in some open access journals to require code as well? The short answer is yes. Jeremy might be more on top of this than me, but if you look at the Software Sustainability Institute, they do this, don't they? They talk a lot about this.
Yeah, I was going to just to respond to that. I was going to say I think that's a great question, and as Andy said, yes, definitely. There's quite a lot of there's different aspects to this. There are now journals that are specifically designed for actually publishing software. So it's often been the case that software doesn't get quite the same representation within the kind of as a research output as traditional publications. So there are now journals such as things like the Journal of Open Research Software, the Journal of Open Source Software. I think there's a journal, Software X. That's also quite a common software, a widely known software journal. And in all of these cases, they don't just require the code; they actually review the code, as far as I understand. So they actually will look at particularly the Journal of Open Source Software focuses very strongly on kind of reviewing the code itself and the practices used and the various different approaches that you use for your sort of testing and so on. On the other side, there's the kind of the more traditional research journals where, yes, I think definitely this whole idea of reproducibility is now much more something that's brought much more to the fore than it was previously, and it's very common for them to require that if you publish research that where you've published some outputs that have been produced using code, that they want to actually see the code, and exactly the kind of things that Andy was showing in the last sort of hour or so with Zenodo and these various other tools are the kinds of things that people are using to get DOIs to represent their kind of software, which is, once it's containerized, it makes reproducibility much easier. So there's lots of things in that space. Andy's put a link to some material from the Software Sustainability Institute in the chat there, I can see, which is a great place to start. So I hope that gives you some sort of pointers, but yeah, I think that's a really good question.
Yeah, I think it's it's something that's going to become more and more common and required. And at the moment, there are some specialist journals which are pointed at there, but as Jeremy said, the mainstream journals are starting to pick this sort of thing up, and problems with research software and the provenance of software are starting to, and the reproducibility of software are starting to enter the minds of the sort of standard journals. There's various people who have been highlighting these problems. There's the guy, can you remember his name, Jeremy? He wrote lots of books. He had a column in the Guardian, and he's a sort of comedian as well, but he's actually a real researcher who highlights these sorts of problems.
I know who you mean, and also
is it Ben Goldacre?
It is indeed Ben Goldacre.
Yes.
So Ben Goldacre has been pushing this as well on a sort of more high-profile celebrity front, and it's particularly gaining traction in things that are really life or death, so medical research and the provenance of those sort of things. So I think it's something it's coming on. So I know people are having to leave because we're at 4 o'clock. It's only in the UK anyway, so, and that was when the advertising session. One thing I want to say before I leave is we've got day 2 tomorrow, which just starts at 10 o'clock, where we're going to talk about. Jeremy's going to be leading more on the Singularity side of things. One thing I would say is that if you've managed to connect to ARCHER2, that's just great, and it's all working. That's brilliant. If you've having problems or you haven't had a chance to test your SSH connection, please have a go at that. Jeremy and I will both be there from 9:30 tomorrow, and we'll be able to help debug any SSH connection issues that you're having. So if you've not been able to connect to ARCHER2 or you're having trouble connecting to ARCHER2 and setting up the account, then please come along a bit earlier or try and help, because to actually use Singularity, you'll need to be able to log in to ARCHER2. Really, there is probably a convoluted way to make it work on your laptop, but it's much easier if the login's just working. It'll make it much simpler for you on the course tomorrow. So please, if you're having problems, join earlier. If you're not able to join earlier for some reason, you're still having problems, then don't worry, a huge amount. We'll have helpers on hand, and we can go and debug the connection to make sure everything's working. But from my side, I just want to say thank you very much today. I mean, it's been really good, the interaction and the questions. You know, they really made me think as well, and they give me some ideas for improving the material going forward as well. So I mean, that's all I can want, all I can want from it. So thank you so much, and hopefully I'll see you all tomorrow morning, bright and early. Or well, maybe not early because it's 9:30, but it might be early for some of you because you might be in different time zones.